loud? No? What? If it's too loud, let me know. I think it's going to start screaming. How are you tonight? Well, that's good. Did you hear that? Fantastic. That's the way to start. And Will is videotaping, so he's going to try to upload it probably by 10, 11 o'clock tomorrow. So if you want to see it again before your exam, you can do it. Otherwise, you can use it for your final. So how many people want me to start with part 1, part 2, or part 3? Part 1. Your hands. Part 1. Part 2. Part 3. Okay, so we'll start part 3. Did you understand what I'm asking? Yeah? Okay. Are you here now? Are you here? Now? Are you here? For those that they talk, no one is here. They are somewhere else. I'm here. In the future or in the past. You cannot talk almost all the time and be in the present. You're talking about what happened in the past and what you plan to do in the future. That's not a pretty good state of affairs. Not to be at the present. Okay, so this problem has 4 questions. What do we have? We have a base. The problem, I think it's making kind of the problem that will say the base is strong or weak, but if you see a equilibrium constant, then you know it's weak, right? So you have a weak base with equilibrium constant Kb, you know its initial concentration, and you want to find the pH. pOH, sorry. Right? So you remember, there is different ways of doing it. You don't have to waste time. The way we said how we do it, to do ice tables and all this, right? You can, so let's go for the A. We've said that if you have a weak acid or weak base, we have that little equation, right? So for the base, we have weak base, we have the concentration of hydroxide ions. The equilibrium, of course, right? Equal to square root of. Remember Maca? So now it's going to be MB KB, right? The corresponding equation, analogous form. And we say we can use this equation, but before we do that, we have to check the ratio MB divided by KB, which is larger than 100. So your question, is it larger than 100? So, if you put the values, molarity of B is, of the base is 4.0 times 10 to minus 2. And the equilibrium constant is 1.0 times 10 to minus 4. You're asking yourself if this is larger than 10 to square. And you can really do this fast, right? You can see which that will make it 400 larger than 100. Right? So it's true. Yes. So with that check that you do, right? That this is larger than 100, you can use this equation, all right? So the only thing you have to do is just put the values, that's it all the time. If this is not true, then you will have to solve the quadratic equation, right? So it's going to be what? Molarity is what? 4.0 times 10 to minus 2 times kb. Okay, and that after calculation should give you 2.0 times 10 to minus 3. Okay, that's the concentration of hydroxide ion. So from the definition of POH, because that's what you want. You don't want pH, you want POH. From the definition, you can find out what's the POH. So POH, you put the value there. Should give you 2.7. Same thing with the weak acid. If you have a weak acid, you just check Na divided by Ka if it's larger than 100. If it is, then it's going to be concentration of hydronium ions. When you talk about acid, it's going to be hydronium ions, maca. If it's base, it's going to be OH minus. So don't be confused to think that it's hydronium ions concentration all the time. It depends. If it's acid, hydronium ions. If it's base, OH minus. Right? Simply from the equilibrium constant, which is yes? Huh? How many people want me to do that? To use ice table? How about if you stand at the end? Okay, do it at the end. Okay, that's A, right? Let's go to B. What's the percent ionization? So, somebody who really understood these things, you can just do it in seconds now. It just takes the ratio of the appropriate values and does it really fast. But if you're not at that point to be able to do it without writing any equations landing down, then we'll have to do it. Okay? Because I don't know where you are. So, things that you don't really need to do for doing your sum, you can just do it in 5 seconds. But let's do it because most of you probably do not know how to do it really fast. So we have a base, weak base, Brooks-Miller base. We don't care what it is. It could be ammonia, we don't care. And the ionization equation will be this one here. Of course, aqueous, will be fast, okay? So by definition, the percent ionization should be equal to the original concentration of the base we put in, how many moles per liter you put in, right? So it's going to be initial concentration of the base. That should be a fraction times 100. So here should be something smaller than the original B. So that's basically the concentration of how much of this reacted, right? 1 gives you 1. So if we want how many reacted, that which reacted, it will be equal to the concentration of this, isn't it? You agree with that? Percent ionization, how much I will ionize, divided by how much we put in. The one that was ionized, reacted, should be equal to the concentration of this. Why? Because one reacts with one, and so if the one that they react